Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Wanur Ayuni binti Muhammad Jamal, and today I will present about characterization of low-cost capacitive soil moisture sensor for IoT network. Okay, the first one is abstract. For the abstract, IoT has advocated for the development of existing practice in greenhouse technology and agriculture in general via automation and computerization, and a research on characterization of a productivity and low-cost capacitive coplanar soil moisture sensor has been carried out to be hosted in dispersed node to apply for IoT system. And this type of capacity sensor relies between the output voltage and gravimetric water content to function. Okay, for the introduction, IoT or Internet of Things refer to a global network of intelligent objects or things based on sensor. Sensors are designed for collecting information such as temperature, pressure, light, humidity, soil moisture, and many more. And soil moisture is a matter of great importance in agriculture. The sustainable use of irrigation water is a main concern for agriculture, and not only under scarcity conditions, and to achieve less water consumption through better management, modernization and automated scheduling of irrigation system, demand for sensor-based equipment. So for this study, a sensor was chosen, and this type of sensor SKU SEN 0193 is the cheapest and easily available in the market as shown in the picture. Okay, so in this experiment they're conducting two, which is sensor calibration with constant GWC, and also sensor calibration at constant soil volume. For the first one is the method they use 7.5% constant gravimetric water content with total sample volume as the parameter. First, the sand is oven dry, which is silica sand, and then the material was poured in graduated cylinder. 77.5% gravimetric water was added and mixed with hand, and then two capacitive sensor was placed into the soil in two different positions, and then repeated measurement was taken. So the result obtained show the sample preparation strongly influenced the capacitive sensor measurement. And the second method is sensor calibration at constant soil volume. The procedure is similar to the previous one, but the only difference is they are using 8 different weight of distilled water, range from 2.5% to 20%. And then the two capacitive sensors were driven in two different positions, and the data show low probability for a linear relationship between output voltage and the GWC. Okay, for the discussion, the study showed that porosity severely affect capacitive soil moisture measurement, and the coplanar capacity sensor yield a reliable relationship between output voltage and gravimetric water content and different type of soil, and for different value of the dry unit weight, a calibration is required. And for the conclusion, the obtained result indicate that sample preparation strongly influence the capacity sensor measurement at different level of soil sample compaction, induce significant relative difference of the sensor output voltage, and for the constant sample volume characterization were carried out, and a well-defined trend of the output voltage as a function of GWC was found. So for the recommendation, more studies should be conducted to understand on how the low cost capacitive soil moisture sensor for IoT was operated, and then to see the effectiveness and accuracy of the data obtained from the capacity sensor. And this is the reference that I have referred to for my assignment. That's all for me. Thank you.